Not yet. We'll get to the math. We'll get to the math probably on, I'm thinking on Tuesday. Yeah, we're not going to finish. This topic will not be done today. It's going to take us a good 2 days to get through. This brings up a good question, actually, Danielle. We're going to learn lots of ways to test lots of different kinds of data, all of which are proportions and averages. Once we get the idea of this 10-step down, we're going to go pretty rapidly from day to day, picking up basically like a new test. If you will, a toolbox with a bunch of tools. It's going to take us a while to get that first tool in there. But once the first tool is in, like learning how to use a screwdriver, a Phillips head screwdriver, learning how to use a flathead screwdriver is a piece of cake. You just have to know when to use it. And then using a torque screwdriver, or using a number 3 versus a number 2 versus a number 1 Phillips. I mean, once you know how to use a screwdriver, changing the bit, if you will, is fairly simple. Oh, no, this is, and thank you for that, because this is an idea I had when I started using your guys' open source textbook. They have something like it in the back, and I was like, well, that's a neat idea. But students didn't like the one in the textbook. So I made it more boxy and more blocky and more circly and fill-in-y. And even though I made a bunch of those words right then. But that seems to work better. So what we're going to do is we're going to learn how, I have to hold a copy with me to make sure I don't skip a step. So traditionally, I remember learning this 20 years ago, we didn't have the template, and it was learning all these pieces kind of as you went. It's nice to have the template going. So the first thing I have to ask is, without the template, do you think this flu vaccine is worth marketing? We got to vote for no, we got to vote for yes! Love it! Anybody say, hell if I know, that's why I'm sitting in this class at 8:15, right? Hell if I know. One of the reasons I came here is to answer that question. So the question is, I don't expect you to know right now. So do you think it is based on that sample data? So who says yes, it appears to be working? Amaya's got a vote, we got a few votes for yes, we got 5, good. Any reason why you guys say yes? Just a gut feeling? Or? No.
Gut feeling.
No gut feeling!
12% of 1,000 is 120.
Okay.
So it would, and 101 people got the flu, so it would be less than 120.
So what Amaya is saying is, we already know people get the flu in this population. They get the flu at a certain rate, and that certain rate is 12%.
And some of them are exposed before they get the shot.
And let's assume that's all controlled for. If you don't mind, Frankie's got a very good point. And this no, please. I never ever don't want to hear those points. The thing is, it goes into what I said before about the collecting of the data.
Yeah,
we can only do so much in 10 weeks. So let's assume the data is good and controlled for. The only difference is those folks in our study got the vaccine. In every other way, they are similar to the population. They're drawn from that population. I know what you're saying, and we're assuming that mix is equivalent for both our experimental group and general population. Thank you for that. Very good. So, Amaya says 12% of the population, or 120 of the 1,000, should have gotten sick. And that, of course, has a bell. The central limit theorem says it has a bell. Where did we land with our sample? Where did our sample land? Right, 10%-ish, 10.1%, yes? So now the question is, right, is 10.1% correct? Because 101 out of 1,000 is 10.1%. So clearly, where is it with respect to 12? It's to the left. Where to the left? I just told you, Rule, to the left. But you've learned now in statistics that all lefts are not equal, correct?
Define left.
Good. So left is that way from 12, negative from 12. But here's the question, Nick. Okay, everybody, you ready? I'm going to start going. Raise your hand when I should stop at 10.1%.
Wait, hold on.
Go.
What's the scale?
I didn't tell you that. And I'm asking you to tell me what you think the scale is.
Okay.
So, good. Thank you for that, Natasha. Thank you, Blake, for seconding that. So I saw one hand pop up when I got to here. So there's 10.1%. There's a question mark, because we're not sure if that's right. Some of you didn't vote yet, so I'm going to keep going. What do you say? What do you say? Go ahead, be brave! Be brave! There's no way for you to know this answer right now. There is no way for you to know this. There is a calculation you could do. But if you're not doing it, I actually like the fact that you're not doing it more than you are doing it. 10.1%, question mark. I only see 2 or 3 hands so far. Duh! So now the question is, and Natasha, the fact that you asked that question just gets right to the heart of the matter. What is 1% on this scale? Because that tells us the whole story, yes? If this is where 10.1% is, what do you guys think? is our drug working? If this is 10.1%, is our drug effectively, statistically significantly working? Because what is this, Austin? This is a N. This is well within the 12% confidence interval, if you will. How about this 10.1% over here? That's becoming a... It's beginning to be... And of course, all of it's because of the way I've drawn the curve, too, right? I've drawn the curve in such a way that makes it a little tricky to know where 95% is. Thank you for that. So this is... How about this guy? It's starting to look like it now. How about Nick's? Is this yours, Nick? I forget if this was yours or not. This was yours. This was yours. Yeah, this one's looking like it's pretty close. How about this one out here? This one appears as though it definitely is. Most of you that haven't voted, I can only assume that means you think it's way down here. So it sounds like either by vote or by withholding your vote, most of you think it works. But all of this hinges on where the scale is, yes? Today, what are we going to learn? Where the scale is. That's what today is all about. Where the scale is. See, the article just simply gives you the result with no mention of the scale. And in a lot of ways that's okay, assuming you did the math correctly and the statistics correctly. Today I want you to understand the ruler that is not apparent right now from our discussion. Anybody can look at the number 10.1% and go, yes, that's less than 12%, and be done. But you know in this class that less than doesn't always mean less than. Just because it's numerically less than ignores the margin of error. I know, Natasha, that's what I'm saying. Less than, that's what I'm saying. That's what I'm saying. There's a margin of error on that 12. There's a margin on that 10.1. Both of which have to be accounted for. Yes? Yes. Let's get into it. Let's get into it. All right. So, the first thing, let's grab our